and so that's not a valuable solution. How about choice 4? Choice 4 shows the same oddity at age 5, open circle, meaning Morgan's age 5 and is not in any division. Look at the next birthday, age 7, 2 open circles. Morgan is in no division at age 7. That doesn't make sense. We see that happens again at 9, 11, and 13. Graph 4 doesn't make any sense. And so choice 1 is our answer. In exercise 8, we want to know which statement is not always true. If we think about what we know about rational and irrational numbers, we probably determined that choice 2, the product of two irrational numbers is rational, is not always true. Sometimes it is, sometimes it's not. Consider this example. An irrational number times an irrational number can be rational. The square root of 18 times the square root of 2, both irrational numbers, give me the square root of 36, which is 6, a rational number. That example might make choice 2 seem like a true statement, but consider this example. The square root of 2 times the square root of 3, both of them irrational, equals the square root of 6, which is irrational. Choice 2 is the answer. In exercise 9, we're given the graph of a function. This is a square root function, and we're asked to determine what the correct domain is. Domain refers to the x values, the inputs, left to right. Range refers to the y values, the outputs, low to high. In this problem, we're interested in the domain. Let's take a look at the x-axis. The values for x that make sense begin at -4 and move on to the right. Choice 1 and choice 2 don't make sense. X is greater than 0 or greater than or equal to 0 because we have x values down as far as -4. Now, which is it, choice 3 or choice 4? Well, if we look at the graph, we can see that there's a closed circle at -4, which means that x is greater than or equal to -4 is the answer because -4 is included. If you weren't sure, you could always put the equation in your graphing calculator and look at the table. Notice that -4 is included in the domain. The output is 0. And so choice 4 is our answer. X is greater than or equal to -4. If you take a look at -4 and substitute it in, you could do that algebraically, you'd find that f of -4 equals 0. The input -4 gives you an output of 0, so -4 is included. In exercise 10, we want to know what the zeros of the given function are. There are several ways we could find the zeros. Let's take a look at a few of those options. The first option is to factor. Find numbers that multiply to -30 and add to -13, -15 and 2. Factor. Take each factor and set it equal to 0. Solve the resulting equations. X equals -2, x equals 15. Choice 4 is the answer. Another way we could do this is by using the quadratic formula. Set the equation equal to 0, identify the a, b, and c value, and substitute into the formula and solve. When we do that, we find that x equals 15 and x equals -2. Those are the zeros. Again, choice 4 is our answer. Another option would be to look at the graph. You can put the function in your graphing calculator and find the zeros. You see a 0 at -2, 0, and a 0 at 15, 0. -2 and 15 are the zeros. Again, choice 4. You could also look in the table. Notice in the table that at -2 we have an output of 0, and when x is 15, we also have an output of 0. That tells us again that our zeros are 15 and -2. In exercise 11, Joey enlarged a 3x5 photograph on a copy machine. He enlarged it 4 times, and the table shows the area of the photograph after each enlargement. We want to know the average rate of change of area from the original photograph to the 4th enlargement, round to the nearest 10th. Average rate of change is the slope formula, y2 minus y1 over x2 minus x1. We want to know the average rate of change from the original photograph to the fourth enlargement. Identify those values in the table, and those are the points that you will use in your slope formula. Identify the values as x1, y1, x2, y2, and substitute them into the formula. When we do that, we find that the average rate of change is 5.4. And so, choice 3 is our answer. On exercise 12, we're given a graph and 3 equations. We want to know which equation or equations, there could be more than one of them, could be used to represent this graph. Let's take a look at the zeros of the graph. Notice we have zeros at x equals -2, x equals 1, and x equals 3. That's where the graph passes through the x-axis. Which of the choices have these same zeros? We can do this graphically using the graphing calculator or algebraically by factoring. If we use the graphing calculator, what we do is we put each of the equations into the graph and look at the zeros. The zeros for equation 1 are at -2 and 6. Those aren't the correct zeros, so equation 1 is out. Equation 2 has zeros at -2, 1, and 3. Those are the same zeros, so equation 2 could be used to represent the graph. That's a possibility. How about equation 3? Equation 3 has zeros at -1, +1, and 6. Nope, that's not correct. It looks like equation 2 is the only one that has the same zeros, and therefore it's the only one that could be used to represent the graph. Read the choices carefully, and we see that choice 2, equation number 2, is the correct answer. How about an algebraic method? We could take each of those equations and factor the trinomial piece. When we do that, we end up with factors that can be used to identify the zeros. Set each one equal to 0 and determine which one has the zeros at -2, 1, and 3. Again, choice 1 and 3 do not have the correct zeros, so they couldn't possibly represent the graph. But choice 2 does, and again, choice 2 is our answer. In problem 13, we're told that a laboratory technician is studying the population growth of a colony of bacteria. He records the number of bacteria every other day, as is shown in the table. T is the amount of time in days that has passed. F of t, the output, is the number of bacteria in the colony. Which function accurately models the technician's data? The easiest way to solve this problem is to take each of those equations, put them in your graphing calculator, and look at the table of values that goes with it. Which table of values matches the table that the laboratory technician had made? Look carefully at the table and notice that the one that has the matching values at 0, 2, and 4 is choice 2. F of t equals 25 to the t plus 1 power. And so we've identified choice 2 as our answer. In exercise 14, we're given 4 quadratic functions. Which one has the largest maximum? Let's use our graphing calculator to find out. Let's take a look at the first function. Put that in your graph and locate the coordinates of the maximum. The maximum is the largest y value, the largest output. We see here for the first function that the largest output is 6.25, and so that's the maximum for choice 1. Now, let's take a look at the second function. Again, let's put it in our graphing calculator and find the maximum. We find the maximum y value is 11.2, and so the maximum for choice 3 is 11.2. For the second option, we're given a table of values, and it looks like the maximum occurs somewhere here between 1,9 and 2,9. We can find the equation for this graph by putting it into a list and spreadsheet and performing a quadratic regression. Take that equation, put it into the graph, and look at the largest value. 9.5 is the maximum for choice 2. How about for choice 4? Here they gave us a graph. The maximum is easy to find. It looks like it's approximately somewhere close to 4.3, and so we'll say the maximum is approximately 4.3 for choice 4. Which one has the largest maximum? Look closely, and we see that choice 3 has the largest maximum, and so choice 3 is our answer. In exercise 15, we're given two functions, f of x and g of x. At which value of x is f of x less than g of x? Substitute the values in and evaluate the function for each of the choices, f of -1, g of -1, f of 2, g of 2, f of -3, g of -3, and f of 4 and g of 4. Then compare. Is f of x less than g of x? When we look at the choices, we see that the first one, yes, choice 1, 1/3 is less than 3. The inequalities for choice 2, 3, and 4 are not true. And so for which value of x is f of x less than g of x? Choice 1. And so choice 1 is our answer. In problem 16, Beverly did a study. She collected data from a cafeteria, recorded the sales each week for ice cream and for soda. She did a linear regression, found a line of best fit, and the correlation coefficient. Correlation coefficient tells us the strength of the linear model. Remember, correlation coefficient goes from -1 to +1. -1 is a perfect fit with a negative slope. +1 is a perfect fit with a positive slope. A correlation of 0 means there really is no correlation at all. The points are just randomly scattered about the scatter plot. Which information can be concluded from this graph? Read the three choices carefully. Eating more ice cream causes a person to become more thirsty. Now, be careful, because while there's a strong correlation, correlation does not suggest causation. Correlation means, yes, there's a linear relationship. As more ice cream bars are sold, more cans of soda are also sold. However, it does not suggest that eating more ice cream causes a person to become thirsty, and so choice 1 is out. Option 2, drinking more soda causes a person to become hungry. Again, there does seem to be a correlation where as you sell more ice cream, you also sell more cans of soda. But once again, the word that causes the problem is the word causes. We can't determine a cause and effect relationship. We only know that there's a correlation. And so choice 2 is out. Option 3 says there's a strong correlation between ice cream sales and soda sales. This is true. There is a strong correlation. The correlation coefficient is 0.96, which is very close to +1. So there is a strong correlation between ice cream sales and soda sales. Just be careful not to accidentally think that strong correlation suggests a cause and effect relationship. It does not. Read the choices carefully. Only option 3 is a correct conclusion that can be drawn, and so choice 2 is our answer.